Hi everyone, I hope you're okay, and I hope that the videos will keep uploading and helping you out. On this video guys, I'll be tackling the fourth question from the May-June 2024 Physical Science Paper 1 exam. And please do expect a total number of 10 videos since there are 10 questions in this question paper, and each and every question will have their own video. And it's very important for you guys to know how to tackle exam questions. I strongly believe it will give you an edge whenever you write your exam. So please do share the video to your peers so that they may have the same edge as you. Two trolleys A and B of mass 3.2 kilograms and 2.6 kilograms respectively are held at rest on a straight horizontal frictionless track with a compressed spring between them as shown in the diagram below. Okay, this is the description of the two trolleys just before the spring was released. Okay, and then after the trolleys are released, the spring extends to its natural length and then falls onto the track. Trolley A now moves at a constant velocity of 0.4 meters per second to the left, while trolley B moves with an unknown velocity to the right. Trolley B reaches the end of the track after 1.3 seconds. Okay. First question, they want us to state the conservation of linear momentum in words. It simply states that in an isolated system, the total linear momentum is conserved. Or you can say in a closed system, the total linear momentum is conserved. Are you together? When they say, guys, remember that momentum is a vector quantity. Né? When they say it's conserved, that simply means the magnitude must be the same and the direction must be the same. Are you together? That's how you keep constant a vector quantity. Are you together? For a vector quantity, both magnitude and direction should be kept the same. But the principle simply states in a closed system, the total linear momentum is conserved. It ends there. Okay, now they want us to calculate the distance traveled by trolley B in 1.3 seconds. Ne? We must just calculate the speed, the constant speed of the velocity of trolley B. What do we know? The first thing we need to do is to choose a positive direction. If we choose the right hand side as positive, that means we'll simply say the sum of the momentas before the spring was released is equal to the sum of the momentas after the spring was released. Né? But initially, both of them were at rest, guys. So I don't need to say the momentum of A plus the momentum of B because they were at rest. But for interest's sake, let me write that. Né? Just for you to have full marks. So it's the momentum of trolley A plus the momentum of trolley B. Né? Momentum is mass multiplied by the velocity plus the momentum of B before collision, or rather before the spring was released, and then do the same thing for the final collision. The momentum of trolley A just after the spring was released plus the momentum of trolley B after the spring was released. Né? Remember that, guys, momentum is just the product of mass and an object's velocity in the direction of our velocity. Okay, initially, both trolleys were at rest, so it was 0 over there. 0 plus 0 is equal to, for body A, I have 3.2 kilograms multiplied by negative 0.4. Remember, I've chosen movement towards the right as positive. So that's negative 0.4 plus 2.6 multiplied by the speed of trolley B. I'm expecting the speed of trolley B to be higher than that of trolley A. Why? Because the mass of trolley B is smaller. But it's fine. 3.2 multiplied by negative 0.4. This will simply give me negative 1.28. If I take it to the other side, it will be positive 1.28. 1.28 is just equal to 2.6 multiplied by the velocity of B after the collision. Why did I say I? So just divide both sides by 2.6. I'll simply get a final answer of the velocity of trolley B after collision as 0.49 meters per second towards the right. That's the velocity. Are you together? And hence the distance, guys. Distance is just speed multiplied by time. Speed multiplied by time. I don't need to use equations of motion. Why? Because I was told that trolley B will move at a constant speed. Constant speed simply means there's zero acceleration. So if I know the magnitude of the speed, that's 0.49 multiplied by the time, which is 1.3, I can simply find the distance covered by trolley B. 0.49 multiplied by 1.3, this will simply give me 0.637, basically 0.64 meters. So our trolley B has covered a distance of 0.64 meters. Okay, and then now we are told that the average force exerted by the string on each trolley while they were in contact with the spring is basically 42 newtons. Not 42 rather, but 4.2 newtons. They want us to calculate the time it took the spring to extend to its natural position. Okay, this force, guys, was exerted in both blocks. Are you together? So I can simply use trolley A. I know that F net multiplied by the change in time is equal to the change in momentum of an object. So the change in time is equal to the change in momentum all over F net. So the mass of object A is 3.2, and then the final velocity, it was negative 0.4 because it moved at a constant speed of 0.4 meters per second to the left. But the initial velocity, this thing was at rest. So the initial velocity was 0. All over 4.2. But since trolley A is being pushed towards the left, that means the F net exerted on A is towards the left as well. So that's why it's negative. So whenever I calculate, I'll simply say 3.2 multiplied by negative 0.4 minus 0 all over negative 4.2. And then this will simply give me 0.3 seconds. This will simply give me 0.3 seconds. So the period, the amount of time it took for the spring to move from it being compressed and for it to be extended to its original position or shape, it only took 0.3 seconds. Okay, trolley B is now replaced with trolley C, which has a larger mass. The same compressed spring is placed between trolleys A and C. The trolleys are then released. The average force exerted by the extended spring on the trolleys remains as 4.2 newtons. Excuse me. For the same period of time calculated in 4.3, how does the magnitude of the velocity of trolley C compare to the velocity of trolley B after the spring has fallen? Okay, the speed, guys, will decrease. Why is the speed decreasing? Because whenever I'm increasing the mass, according to Newton's second law, the mass of the object is inversely proportional to the acceleration. Are you together? If if ever I increase the mass, that means I'm decreasing my acceleration. Are you together? But what do I know about acceleration and velocity? Acceleration is directly proportional to the change in velocity. If acceleration decreases, so does the change in velocity. Are you together? So whenever my change in velocity decreases, that means the final velocity will decrease because the initial velocity was 0. So basically over here, acceleration is directly proportional to the final velocity. So if that decreases, the velocity decreases as well. Yeah? And then how are you going to answer? You are simply going to say, whenever the mass is increased, the acceleration of the object will decrease, and with a decrease in acceleration, it simply means the object's final velocity will also decrease as well. That's how, guys, we should answer that question. Yeah, just stay tuned, guys, and wait for more videos.